So to start Unit 6, we're just going to start with one exponent property, and that is determining the relationship between radicals and rational exponents. Rational numbers are any numbers that it's possible to write as a fraction. So we have fraction exponents, but we use the math vocabulary for that. So rational exponents. This is the property, and I changed it on your example here, but I didn't change it down below where these are defined. So if you want to, it had N and M, and I felt like sometimes that's confusing, so I changed it, the power, to P. N is for index. I felt like that was reasonable. And then I changed the power to P. Power, you raise it to a power. That's the exponent. When I write it like this, this is actually both, all of this is an exponent. So it should be a big X as a base and P over N actually as the exponent. If that's easier to see, then rewrite that for yourself. Because it kind of looks like these are multiplied together, and that's not what the intention is. Index will be this small number outside. That'll be the denominator when you rewrite this as an exponent. And the power will be the numerator. So that's the top. And this is where I tell my story about hats and boots. I found this somewhere. I didn't make this up, but I like it. So I bring it along with me and share with you. If you're somebody who wants to tell yourself a little story so that you remember things. X is a cowboy, and he has a hat and boots, as you know, cowboys do. So we like to keep the hats over the boots. On a good day when the birds are tweeting and the sun is shining, you want your hats over your boots. If I wrote X with an exponent, which is kind of a stretch, I guess, for my story, I would want the hat over the boots. And that's like a life goal. Make sure your hats are over your boots. Okay, so it goes like that. When X goes home, though, I got X in the house. He can wear his hat inside the house. But the boots have to stay outside the door. So if you hear me saying hats and boots, this is what I'm talking about. The index is the bottom of the fraction, and the power is the top. Hats and boots. Okay? And right under this, it says, okay, well, why does this work? So let's relate this to how we were simplifying radicals. Here I have cube root x to the 6th. By the way, sometimes you see this as, it's also may be written as cube root of x, and then that's raised to the 6th power. It doesn't matter if you do cube root and 6th power, cube root first and 6th power second, or if you do 6th power first and then cube root second, it's equivalent. Those mean the same thing. And I bring this up because on your practice, some of them look like this and some of them look like this. If I simplify this the way we did when we were dealing with only the radicals, I would say x to the 6th is the same as 6 x's multiplied times each other. And here we're trying to do a cube root to simplify. Since it's a cube root, I need sets of 3 matching factors. And I do have 2 sets of 3 here. Here's a set of 3 x's, here's another set of 3 x's. So for each set of 3, I can pull out 1 x to represent the set. So I could rewrite this as, oops, one x to represent this first set, and another x to represent the second set. And those are now outside of this cube root, and this is blank. There's nothing left in here, right? Another way to write this then that would be equivalent is that this is x squared. So this is the logic of the explanation, how we were simplifying things with the last unit that we studied. So I'm proposing this exponent property today that you could also write this x with an exponent and an index as x to a fractional exponent, where the power is the numerator and the index is the denominator. And here I got x squared when I simplified. If I rewrite this cube root x to the 6th using this property, then I would write x and for the exponent, I will write the power as the numerator and the index as the denominator. And when I simplify this fraction, 6 over 3, 6 divided by 3 is 2. So I get the same result, but I went about this with a different process. So different mathematical understanding, but equivalent result. Okay? This is why it works. Right underneath here, well, questions right now. We good? Okay. When we had a square root, we talked about it that this, when there's no index written, this means that there's a little 2 out here that we don't ever write because it's a square root. Yes? Also, the x means x to the first. When there's no exponent, it's just the first power. So, therefore, when I substitute these blank spaces and understood numbers that are not written into using this same property, then I would say square root of x with no index and no exponent, no power, could be written as x to the 1/2 power. Okay. under here, I have some examples to do with you. Some of them are written with an exponent, and we will write them as an equivalent radical expression. And some of them are written with a radical, and we'll write it as an equivalent exponent expression. And with both of these, it says simplify, but I marked that out and said we're not going to worry about that right now. Right now, we're just going to change forms, one as the other, and make sure that they are equivalent. And I would write a note here for you. When you're doing this, because you have variables and it's not an equation, and if you want to check yourself and make sure that what you're doing is correct so that you can take some comfort that we're actually doing good, helpful practice, I would recommend substituting a number. I'm going to assign a number to the variable. You can pick any number, it doesn't matter. If you want x to be 2, make x 2. If you want x to be 17, make x 17. It doesn't matter at all. And then when you have an expression here, if I did square root of 2, and I could put that in the calculator and get a value, I could also do 2 to the 1/2 power and verify that that is truly equivalent. So you can check yourself and make sure that what you're writing is good and your practice is accurate. And check with calculator. All right, so these first two, I marked the middle one out. The reason is it has a negative on the exponent, and that's a combination with an additional exponent property, and we're not dealing with that today, so don't worry about this one. I have x to the 2/3, and that can be written as x inside a radical, and I'll put the exponent inside with the x, the 2, the power, that's the hat, and the 3 is the index, that's the boots. This could also be written as cube root of x and then squared later. Either one of those is correct. And as I said, you can substitute a number for x and check that. So when I have x to the 8/5 power, I'll write x in a radical, and what will my exponent, what will be the power, and what will be the index? Where do my numbers go? What goes outside? 5. And inside is the 8. Or I could write it this other way. Down below this, I have some examples that are written with a variable, they do have a variable, with a radical, and we're going to write this as an equivalent expression with an exponent. So I would write cube root of x as x to the 1/3 power, because we said if there's no exponent, no power, then it's a 1. That invisible 1 will be the numerator, and the index is the denominator, so it's 1/3. When you have a number, when you have more than one part in the radical, I recommend using parentheses so that when you rewrite this, use parentheses with groups. Okay, that's kind of a big deal. I have 8 and y inside this radical. So when I write this as an expression with a rational exponent, the 8 and the y both will have an exponent together. Use parentheses. There's no power, so we'll write a 1 for the numerator because it's blank. And there is a root, and it's 5. That's the denominator, the index. Here, for the one just below this, I have 8, and it's multiplied times square root of y to the third power. So now the root and also the power are only going to the y, not to the 8. So when I rewrite this, 8 will still be 8. I didn't do anything to change the 8. This will be 8 times y to the 3 over 2. The y gets the exponent and not the 8. You could also write this as 8 times y to the 3 over 2. But I just really want to make a distinction here that with this problem that we just rewrote, this means that the exponent only goes with what's right beside it, the y. And that's very different from what's just above that, where the exponent goes to both parts of that. Okay. This isn't complicated, you guys. It is very picky and very, detailed and kind of tedious and can be complicated, but it's not difficult. So take your time and use this trick of substituting a number and evaluating an expression to make sure that what you're proposing is an equivalent simplified expression, rewritten expression is truly equivalent. Okay.